of these molecules to make copies of themselves. Remember, we talked about alleles having a fitness back when we talked about the different definitions of fitness. If certain genotypes have different fitnesses, the same thing's going to happen. You get more copies of certain alleles than others during this reproduction process. And what we're assuming here is that this process that we call natural selection can't occur. Because if natural selection occurs, it messes things up. The Hardy-Weinberg equilibrium is no longer valid. All right. Number 3, the assumption that we're going to make is that the alleles can't move between buckets. This idea is that I couldn't have this big A allele from across the street jump into the bucket because that would change the frequency of the big A, and I couldn't have this little A allele decide it wants to leave the bucket because that would change the frequency of the little A allele. So what we're assuming here is that migration doesn't occur. Migration is the idea of moving individuals around and they take their alleles with them. Well, we can't have that. If that happens, we mess up the equilibrium. Right? 4th assumption here, we have to assume that the population size, or the population of alleles in the bucket, is infinitely large. Okay? And what we're basically assuming here is that a process called genetic drift cannot occur. We'll talk in great gory detail about genetic drift, but for right now, you have to assume that the population is infinitely large. And that has to do with what's called sampling error. Okay, so let me see if I can explain a little bit about sampling error a couple of different ways. The first way would be to talk about kind of a coin. So when I took statistics when I was back at your age in the last millennium, in our statistics lab, we had a lab associated with statistics, we flipped a lot of coins. And for the probability part of the lab, we flipped a lot of coins. And the idea is, my expectation is that the probability of picking a heads on a coin flip is 1/2. And the probability of picking a tails is also 1/2. So, if I flip the coin 10 times, the probabilities predict what? Well, the prediction would be, well, 50%, 50%, you should get 5 heads and 5 tails. And then the question is, well, am I going to get that? Well, probably not. I could get 4 heads and 6 tails, or 4 tails and 6 heads, or 8 heads and 2 tails. There are all sorts of other possible combinations that occur because each of the probabilities, heads and tails, they're independent of the previous flip. So each time I flip it, it's a 50% probability, but there's also a 50% chance that I get the other one. So this deviation away from expectation is called sampling error. And the idea is, if I flip the coin anything less than an infinite number of times, there's an associated probability of not getting what I expect. However, if I flip the coin an infinite number of times, I will get 50% heads and 50% tails. It's only in infinity that these probabilities match what you see. The more coins you flip, the closer to 50% you get, but you could still get a deviation away from that expected 50% heads, 50% tails. Okay, another story here. When I was your age, I ran track in high school. Actually, a little less than your age, but I ran track in high school, and we didn't like to run against Mendon. It was a town in Michigan because they had the Cup girls. the Cup girls were from a family. There were 8 daughters. The guy was a farmer. They were very good runners, and we were such a small school, they always combined the heats with the boys and the girls, and you didn't want to be in a heat with the Cup girls because they were going to beat you.